So class, continuing numericals on electrical conductance. Here is one numerical on this. 0.001 molar AlCl3 offered a resistance of 100 ohms when filled in conductivity cell of cell constant 0.386 cm inverse. We are supposed to find out conductance, specific conductance, molar conductance and equivalent conductance. So let us start with conductance. We know class C equals to 1 by R. So 1 upon the value of R is 100. So we'll get value 10 to the power minus 2 ohm inverse. In the next step, specific conductance equals to conductance multiplied by cell constant. Conductance we have calculated, cell constant 0.386 multiply, you get this value. In the next step, we are going to calculate molar conductance. So lambda m equals to kappa into 1000 upon molarity. Kappa we have calculated 3.86 10 to the power minus 3 multiplied by 1000 upon molarity again 10 to the power minus 3. Solve it. We get 386 ohm inverse cm square mole inverse. Units are very important. Then we know aluminium has valency 3, so factor of aluminum chloride is 3. So kappa into 1000 upon normality equals to, let us put the value, and once you put the value, you get 386 by 3, that gives you 128.6 ohm inverse cm square equivalent inverse. Now class, we come to our third topic of electrochemistry, that is electrochemical cell. We'll take example of Danielcell, but before we move to electrochemical cell, we'll be revising some basics. So first is difference between oxidation and reduction. So class, what is oxidation? Increase in oxidation number is oxidation, and similarly decrease in oxidation number is reduction. And number 2, removal of electron. Removal of electron is your oxidation, and acceptance of electron is your reduction. We can take one example here. After removing one electron, gets converted to Na positive. So class, you see here, it is moving from 0 state to +1 state. So oxidation taking place. Similarly, Cl, after consuming one electron, gets converted to Cl negative. Previously it was 0, now it is -1. So decrease in oxidation number, therefore it is reduction. Class, in the next topic, we are going to understand cell identification. How you are going to identify anode, cathode, negative, positive, all can be discussed here. So class, they follow alphabetical order. As per alphabetical order. Class, in electrochemical cell, there are two electrodes. One is your anode, other one is your cathode. So A comes first, C comes afterward. Then class, negative and positive. So anode is negative because N appears first and cathode is positive. If we talk about oxidation reduction, anode, oxidation takes place because O comes first, followed by reduction at cathode. And while writing the cell representation, we always take anode on left hand side and cathode on right hand side. So you see that they follow alphabetical order. A comes first, C come afterwards, N come first, P come afterwards, O comes first, R come afterwards, L come first and R comes afterwards. So It is very easy to remember. You can very well identify your electrochemical cell. Now class, your next heading is Danielcell. It is very easy to prepare. Let us take 2 beakers. In first beaker, we have taken jet rod, dipped in zinc sulfate 1 molar. Another, we have taken copper rod or copper plate, dipped in copper sulfate 1 molar. We connect these 2 electrodes with the help of a wire along with a switch and a load, that is our bulb. So class setup is very easy. Zinc is dipped in zinc sulfate 1 molar, copper is dipped in copper sulfate 1 molar, and when we just press the key on, the bulb starts glowing. So it means that chemical energy has been converted into electrical energy. So what are the theories behind this that we are going to discuss just now? But at the present moment, what we studied here, zinc is dipped in zinc sulfate and copper is dipped in copper sulfate. So class, very important thing, cell theory. It simply states that higher the reduction potential, more is the tendency to get reduced at cathode. Class, this line is the basic of entire chapter, that is called electrochemistry. Higher the reduction potential, more the tendency to get reduced at cathode. So how to find out which has higher potential? So class, these reduction potential values are always given to you. I am going to write here Zn plus 2 giving me Zn0. The value is minus 0.76 volt. Copper 2 plus oblique copper 0. The value is 0.34 volt. These are the 2 dots which we have taken, and their reduction potential values. How we can say that it is reduction potential value? Now see, the Zn plus 2 is moving from plus 2 state to 0 state, so decrease in oxidation number, so it is a reduction potential. Similarly, plus 2 to 0, again reduction potential, reduction taking place, so that's why these values are reduction potential. So whenever we are going to compare the reduction potential values, it will be always in reduction potential, though we know that at anode oxidation takes place and at cathode the reduction will take place, but while comparing, both the values should be reduction potential. If we compare these 2 values, we find that copper has high reduction potential, so copper will be going at cathode and zinc will be going at anode. Once you understood this, then let us move to what reactions are taking place. So class, at anode, zinc is getting oxidized, so I will write the reaction of zinc, Zn0 giving me Zn plus 2 electron. So you see very well that Zn is getting oxidized. At cathode, copper 2 plus consumes the 2 electrons liberated by Zn and get converted to copper 0. If we add both the reactions, 2 electron get cancelled with 2 electron, we get final overall cell reaction Zn plus copper 2 plus giving me copper 0 plus Zn2 plus. If you go through this reaction, you very well find out that Zn is going for oxidation and copper is going for production. Plus, since the bulb has glowed, it means that chemical energy has been converted to electrical energy. But let me tell you class, the bulb glows only momentarily. It just glows for a moment and then it stops. So what is the reason behind that? That it glowed and then it stops. So class, we have to understand the entire thing again. See class, this was my anode and we all know that anode is negative. This was my cathode. We all know it is positive. Why this is negative and why this is positive? I have already told you in the very beginning that anode is always negative and cathode is always positive. That I have already shown to you. And now class, since the copper reduction potential was very high, so copper was going for reduction at cathode and zinc was going for oxidation at anode. What is happening at anode? At anode, Zn0 is getting converted to Zn plus 2. It means positively charged, and since the plate is negatively charged, so all Zn plus 2 ion will get deposited on anodic plate, and ultimately no further oxidation of Zn plate will take place because at the surface it is occupied by Zn plus 2 ion which are not going to be oxidized further. Similarly, what is happening here? Copper sulfate consumes 2 electron and giving me copper 0, liberating sulfate ions. So now class, the plate being positive, these sulfate ions get deposited on cathodic plate, and now further reduction stops at cathodic plate. So oxidation stops at anodic plate, reduction stops at cathodic plate. Therefore, the entire cell reaction stops, and your bulb also stops. So, what was the reason that bulb glowed momentarily? Listen carefully. It is due to extra accumulation of charges on anodic plate as well as cathodic plate. On anodic plate, it was deposited by Zn plus 2 ions, which cannot get further oxidized. Similarly, at cathode, the sulfate ion get deposited on positive cathodic plate, hindering further reduction of copper sulfate. Therefore, the bulb glowed momentarily and finally it stopped. So class, what is the remedy for this? Remedy is salt bridge. I am going to draw here. It's a U-tube. It's both the ends are plugged by cotton wool, plug, and in the U-tube it is filled with either NaNO3 or KNO3 in agar jelly. These jellies are very thick, highly viscous, and hence when we place the salt bridge on these two beakers, sodium nitrate and potassium nitrate are not going to come out. They will come only on the demand. When there is demand of a negative ion here and demand of positive ion here, then these ions are going to migrate from salt bridge. Otherwise, they will be just remaining with the viscous nature of agar jelly. So what is going to happen? And what are the functions of salt bridge? So I'll write here functions. The number 1, it completes the circuit. How it completes the circuit? Class, you see, external circuit is completed by the wires and the internal circuit is completed by the salt bridge. So, with the use of salt bridge, the entire circuits get completed. And second function, it neutralizes extra accumulation of charges. Class, I repeat again, what is salt bridge? Salt bridge is a U-tube where it is filled with either NaNO3 or KNO3 in agar jelly, and two mouths are plugged by cotton wool, and the entire U-tube is placed on both the beakers so that the mouth of the salt bridge touches the electrolyte. So class, it completes the circuit. I have already told you how it is going to neutralize extra accumulation of charges. That can be seen here. Class, when there is extra deposition of Zn2 plus ion at anode, then sufficient number of nitrate ions, negative ions, they migrate from salt bridge and forming ZnNO3 whole twice. Aqueous means this thing will get dissolved in water. So ultimately all Zn plus 2 will get converted to zinc nitrate and it will fall in the electrolyte, cleaning your anodic plate. Similarly, at cathode, when there is extra accumulation of sulfate ions, then sufficient number of positive ions, either sodium ion or potassium ion, they will migrate to the cathodic plate and will form sodium sulfate aqueous, which is again soluble in water. Therefore, all the extra sulfate ions which were deposited on cathode plate will form sodium sulfate and ultimately they will fall into the electrolyte, cleaning both the surfaces, and hence we can very well see that my Danielcell works till the ions are present in the salt bridge. So now the bulb is not going to stop. So class, we studied Danielcell. What was the basic behind Danielcell? Higher the reduction potential, more the tendency to get reduced at cathode. Copper has already shown you. Copper has higher reduction potential, so copper goes for reduction and zinc goes for oxidation. But we found that there was extra accumulation of Zn plus 2 ions on anodic plate, as anodic plate is negatively charged, so Zn plus 2 ion get deposited here. Similarly, there was extra deposition of sulfate ion on cathodic plate, which is positively charged. So we have to use salt bridge. Salt bridge, it completes the circuit that I already told you. External wire completes the external circuit and salt bridge completes the internal circuit. Then function number 2, it neutralizes extra accumulation of charges. At a node, class we find that Zn2 plus ion react with nitrate ion which is migrated from the salt bridge, forming zinc nitrate, and it is being soluble, cleans the anodic plate. Similarly, sodium ion migrate from salt bridge to neutralize sulfate ions, forming sodium sulfate, and again the sodium sulfate being soluble in water cleans the cathodic plate. So both the plates are now clean and hence the cell will function indefinitely.